Dear students, let us continue our learning on the course Data Structures and Applications. We are in the 8th session of the Module 4. In this session, we are going to cover the creation of the threaded binary tree and its usage. Myself, Dr. Suresh.d from the Department of Computer Science and Engineering of Canara Engineering College, Bantwal, Mangaluru. When we go to the tree representation using the linked list, so normally what happens is most of the links will be kept null. So let us take one simple example of the tree. So let the tree be A. We'll have the two children. Let it be B and the C. And B will have one children, D. And E will have one children, let it be A. If the same tree is represented in the linked list representation, it will appear as A, node B, node C, node D, node F. For the A, both the links are used. The left link is connected to the node B and the right link is connected to the node C. For the node B, so one link is unused, that is the left link is unused. The right link is connected to the node D. For the node D, both the links are unused. Then for the node C, left link is unused. The right link is connected to the node F. For the node EF, both the links are unused. If we count the number of nodes over here, so totally we have 5 nodes over here. For the 5 nodes, we have the 10 links. Each node is associated with the 2 links. So for the 5 nodes, we have the 10 links. To generalize, if I have the n nodes, I have the 2n links. Out of these 5 nodes, how many links I am using? 1, 2, 3 and the 4. So for 5 nodes, I am using 4 links I am using. In general, for the n nodes, I am going to use n minus 1 link. So how many links are left blank? Here in this case, 6 links are left blank. So in general, this is a n plus 1 links are the left blank. They are the null nodes over there. That is the null links. Right? So these links, the null links, can we use it for the betterment of the better representation of the trees? That will be your binary trees. That is your threaded binary tree. So the first discussion will be on the limitation of the binary tree. In a binary tree, normally n plus 1 links or null links out of the total 2n total links. So traversing a binary tree is always a time consuming, and these limitations can be overcome with the help of the threaded binary tree. In the linked representation of any binary tree, there are more null links than the actual pointers. Here in this case, actual pointers are 4, the null pointers are 6. That is, we have the more null pointers than our actual pointers. These null links can be replaced by the pointers, which will be called as the threads, which points to the other nodes in the tree. How to construct how to use these threads? That is the next question. How to use these threads? To construct the threads, we use these two notations. We use one pointer that represents a node. If the pointer left child is null, then replace the null link with a pointer to the in order predecessor of the PTR. Then if the right child is null, then replace with the in order successor of the pointer. So let me have the in order traversal for this one. So if you remember, the in order traversal will be the first we visit the left child, then the root, and the right child. The traversal order for the in-order traversal is first we visit the left child, then we visit the root, then the right child. So now the left child. Now no left child, then the root. That is the first one is B. Then the next one, right child. Then the root, then the left child. I don't have the left child. Then the root. That is D. Then the right child. I don't have the right child. Now the left child is done. Then the root. Root is now A. Then the right child. For the right child is now C. Then the left of the C. I don't have the left of the C. Then the root is now C. Then the right child is now F. Now again the left child of the F I don't have. Then the root is now F. So this is the in order traversal. Now if we keep on going for B, I don't have any predecessor. I have a successor. Successor is D. For the D, predecessor is B, successor is A. For A, predecessor is D, successor is C. For C, predecessor is A, successor is F. For F, predecessor is C, I don't have the successor. Now let us use the unused links for that purpose, for representing the predecessor and the successor purpose. Now let me go for removing the link which I earlier made as a null. So now the link field, I will use it for the creation of the thread. In the same tree, I will use the link field, the null link field for the thread purpose. Fine. So first, the left child. If any node, any of its left child is null, then replace the null link with the in-order predecessor. For B, do you have the in-order predecessor? I don't have. So let me use it. Let me connect it. Simply, I will connect it here. Fine. Simply, I will connect it here. Then next, where is the next one for the D? For the D, I have the left child as null. Now you connect. Now look at the D over here. What is the predecessor for the D? Predecessor for the D is a B. So now this link, we will connect it to the in-order predecessor. The left child will be connected to the in-order predecessor. In the same way, now for the D, I have the right child also null. If the pointer of right child is null, then connected to the in-order successor. What is the in-order successor of the D? In-order successor is A. So you connect it to A. You connect it to A. Then next, the C. For the C, the left link is null. The left child is null. Take the in-order predecessor. In-order left child means predecessor. Right child is null. You have to use a successor. In-order predecessor of the C. What is the in-order predecessor of the C? A. So you connect this child to the A. Next, F. Both the childs are null. So now what to do? The left child connect to its predecessor. Its predecessor is a C. Now right child I don't have. So you can connect it to, now it is not connected anywhere. This will be the dangling, this we call it as the dangling link. So how to handle, we will discuss, right? So this is how the threads are created. How the threads are created? If the left child, that is your left link, is null, then you connect it to the in order predecessor. You connect it to the in order predecessor. And if the link field, that is the right child link, is null, then you connect it to the in order successor over there. You connect it to the in order predecessor for the left child, in order successor for the right child if that link field is null. So now let us consider the above tree. So now in the above tree, so let me write the traversal for this tree, in order traversal for this tree. First we will go with the left child, left child, left child. So then no more left child, then the root, that will be your H. Then the root of the H, root of the H is D. After D, now go to the right child. So now the left of the root I don't have, then its root is now I. Then again it is done. Then the root of the D is a B. Then the right child of the B is E. Then the left child of the E I don't have. Then the root is a E. Now I have done the left child of the A. Now go to the root of the B. Root of the B is a A. Now the right child of the A is C. Again you have to take the left child. The sequence is a left child, then the root, then the right child. So after right, you need to again go to the left. After right, you need to again go to the left. So now after the C, C is your right child of the A. Again, you need to go to the left child of the C. What is the left child of the A? C, F. So now no left child of the C. Now the root of the F. Then the root of the F is a C. Then the right side of the C is a G. Left side I don't have. Then the root will be your G. So now this is your in order traversal. This is your in order traversal. The same traversal, the same tree is represented. The same tree is represented with the as a threaded tree in the down over here. Fine. So now as we observe, first the link fields. The link fields. The first link field. Fine. So now for the A, I have both the children. Now for the B, I have both the children. For the D, I have both the children. For H, I don't have the children. The left link is to be connected to the in order predecessor. I don't have the predecessor, so left it blank. So it is left as a blank. Then next, the right one. The right link you have to connect to the in order successor. Successor means next one. H is to be connected to the D. Fine. Then next will be the I. Both the links are null. Left one you connected to its predecessor. Predecessor is D. Then the right one you connected to its successor. Successor is B. The next one E. The E as again the both the links are null. The left link you connected to its predecessor. Predecessor is B. And the next one you connect right child you connected to the successor. Successor is a A. In the same way, go with the F. Predecessor of the F is a A. Connect as the left thread. Then the successor of F is a C. Connect as the right thread. Then for the G, predecessor is a C. Connect as the left thread. Then the right, I don't have the successor. So now it is the dangling case over here. Now these two links are not connected anywhere. Such a links we call it as a dangling threads. Such threads we call it as the dangling threads, but we have to handle that dangling threads. Let us see next one. This is how the threads are created. This is how the threads are created. That is, if the left child is null, the link of the left child is null, then we connect it to the in order predecessor. And if the link of the right child is null, then we connect it to the in order successor over there. For that, you need to first make the in order traversal. Then, if you continue, it will be good. The next. Now I need to handle these two. So what are these two? One is the left, that is the left thread of the first node and the right thread of the last node. So now these two threads are dangling. So these two threads I am not able to connect to anywhere. So these two threads are dangling. Now to connect these two threads, we go for the header node. To connect to these two nodes, we go with the header node. Fine. So the next. In the above figure, the new threads are drawn in the broken lines. The tree has 9 nodes and the 10 null links, which will be replaced by the threads. When threads are represented in the memory, it should be able to distinguish between the threads and the pointers. So to have that distinction, we create them as the left thread and the right thread. So there, for the children, we use the left child and the right child. For the thread, we call them as the left thread and the right thread. The next one, if pointer of left thread equal to true, means that child is null. Thread is true means the child is null. So now if the child is null, so what it will hold? It will hold the address of its predecessor, in order predecessor. Then the PTR of left child contains a thread, otherwise it contains a pointer to the left child. That is, the thread value will be either true or the false. So true means the child will work as if the thread value is true. If the thread value is true, means the child will have the address of the predecessor. The child will have the address of the predecessor. That is, a pointer of left child contains a thread. If it is true, if it is false, then the child will have the value. Means if the right thread is true, means it's the pointer of right child is a thread which will points to the successor, in order successor over there. Fine. So now along with the child. So fine. Now if you take up that one, that is now the left child and the right child. Now let us take the left child and the right child. Fine. So let that tree, let me represent the tree. First for the A, let me take up. So A will have the two children, let me take. So two children are, one is the B, other is the C. Then C will have only one children. Let me take it as D. Fine. So now for the A, both the children. So now we have the four fields now. Along with our data, we have the four fields. One is the thread field. That is the left thread. Let me call it as the left thread. One is the left thread. And the left child. Other one is the right thread and the right child. Now for the A, left thread will be false. The left child will be the address of the B. Now for the B, I don't have the left child, right? So now that will be connected as left thread as true. Left thread will be true. And the left child is the in order predecessor. Left child is the in order predecessor. So as I told, it is a dangling case. Now let us go with the D. For the D also, left thread is true, but the left child is its in order predecessor, which is nothing but your B. Which is nothing but your B. Now the left child will have the value as a B. Now it is not the child. It is not the child. It is not the case. It is its in order predecessor. Fine. So that decision whether to go with the child or to go with the its thread, whether to go with the child or to go with the thread, for that one we are using these thread values as a flag. If the left thread flag is true, means we are going with the thread. If the left thread value is false, then we are going with the child. The discrimination is done with the help of the pointer is the same, child only. There is left pointer and the right pointer. They will remain the same. What they will have, that decision will be done with the help of the thread. So now thread is not a pointer. Thread will have the numerical value. What numerical value it will have? True or the false. True means what? It is the child is having the thread value. False means what? The child is having the child value. That is the children node. Children node it is having. For that is the discrimination what we are making. Now if we go with the node structure, the node will have the total of 5 fields over there. The first one is the left thread, which is a short integer, which is have only the two values, true or the false. Then the pointer, that is your left child, and similarly the right child and the right thread. Then original data will be there in the data over. So this is how we create the thread tree. That is a node in the thread tree. So now if you go with the node in the thread tree, so now this is how it will be stored. Fine. So now if we write the tree again over here, so this is A. So now this will be B. Then on this side I have the C. So next this will be D. So this is E. Then for the C, this is F. Then that is the left child of the C is F. Then the right child of the C is a G. Then for the D, left child is H. Then the right child is I. Now let us start from the A now. So now from the A if we start, so A will have the both the children. So the A will have both the children. So the thread values are taken as false. So because the links what we are using, they are not the threads, they are actual children. They are actual children. Now for the B. Again for the B I have two children. So that is one is D, other is the E. So the thread values are held false. So the thread values are held false. Next for the D, again the thread values are held false because the children of D are H and the I. Now for the H, both the threads are null. I don't have the links. So now this has to point to the in order predecessor. In order, I don't have the in order predecessor. For that reason, I will create one header node, a dummy header node I will create, and I will connect this node to the header node. Fine. So now, are we using the child value or the thread value? We are using the thread value over there. So the thread value will be held true. So in these cases, if you look, you can see the thread value as a false, but now the thread value is true. So similarly for now, let us do the in order traversal of a binary tree. By using these threads, the in order traversal can be performed without making use of the stack. Without stack, we can perform the in order traversal. How to do that one then? Then for any node PTR in a threaded binary tree, the PTR of right thread is true. PTR of right thread is true. Means what? The thread will have what? A thread will have its successor over. The right thread will have the successor over there. That is, the in order successor of PTR is a PTR of right child. That is, to get our PTR, we need not to go back to the previous one by using the stack. It is not needed. Instead of that one, if we just follow the pointer of right child, then we will get our successor over there. Then we will automatically get our successor by the definition of the threads. Otherwise, we obtain its successor by following the left child links. By following the left child links, we will get its successor over there from the right child of a PTR until we reach the left thread equal to true. So once we get that left thread equal to true, only then we will go at the right child to get its successor over there. So let me draw a simple one and let us demonstrate. Let it be the tree A, B, C, D. Fine. So now what is the in order traversal for this one? The in order traversal for, let me have the one more, that is our header node over here. In order traversal is first is left. I don't have the left. Then the next one is a B. Then the right. I don't have the left and right. Then next will be the A. The next one is the D. Fine. So now this is a null. So let me use the dotted line. So now this is a thread. This will be connected and this link will be connected. Then next for the C, the predecessor is the here. The let me write the thread values. The thread value is true. The thread value is true. Then next here let me write the thread values over here. Thread value is false. Thread value is false. Thread values are false. The thread value is false because it is a header node. Fine. Then next one for this one, I don't have the child, so it will be connected to its predecessor. What is the predecessor of the C? Predecessor of the C is B. So it is connected. So the thread value is true. I don't have the right child, so it is connected to its successor. What is the successor? It is A. So this is connected to A. The dotted lines I am using for discriminating between the threads and the actual links. Fine. So now the thread value is true. Next for the D, the left thread is a true. I don't have the children. So now it's a predecessor. Predecessor is a A. The right child is a true. It is its successor. Successor is a, I don't have the successor. I will connect it to the root. Now let us look how the traversal will happen. How we can use the stack. How we can do the in order successor, in order traversal without the application of the stack. So now for the in order successor, to find the in order successor without the application of the stack, how we can do the traversal. Now this is what the tree which has been given. Now we start with our left child. Fine. So now we will look at the thread value over there. Does the thread value is null? No. Thread value is true? No. Again it will come here. Does the thread value is true? Yes. Its thread value is true. The function in order successor the thread value is a true. Now the successor of B is the thread value is a true. So thread value is true. When the left thread is a true, then we have to look at our right thread. If the left thread is true, then we have to look at our right child over there. So now the left thread is true. So now B is the first node. I need to look at its right child. So right child of the B is a C. I will come over here. Again, the left thread is a true. Then I need, so left thread is a true. I will write the value. Then the successor. How to get its successor? Successor is there in the right child. Successor is there in the right child. What is the right child of the C? Where it is pointing? It is pointing to the A. So now I can go to the A. Again, the thread value. We will go with the next one. That is our right child. The right child value, if we take up, that is our D. Again, the thread value. Thread value is true. The left thread is true. Then you need to take up its right thread. The right thread is going to the root. Then we will stop. The right thread is going to the root. Then we will stop. This is how we will find the in-order traversal of a threaded binary tree without the stack. Without the stack. How we can have the without the stack? To find the successor, we need to go back to our previous node. To go to our previous node, we are using the stack. To go back to our previous node, we are using the stack. That leverage we can remove by having the concept of these threads over there. So how it will be used? That is, for any node pointer in the threaded tree, if the right thread is true, means what? The next one, the right child is pointing to the successor element, the next element. Then the pointer of right child by definition of threads is the successor, is the next element. Otherwise, we obtain the in-order successor by following the left child links. Right? The function, what is next in the next slide, that will find the in-order successor for any node in a threaded tree. How it will be done, you can just look. Right? First, we will have the temp will be equal to T of right child. Then next, if that right child is not, if it is null, if it is a not case over here, if it is a false, if it is false, then we need to follow the left child. If it is true, then only we need to return your, we need to go for the next one by using the right thread, by using the right thread. If it is not true, if it is not true, means if it is false, first case. So that is a temp will be equal to tree of a right child. That is, we are creating the threaded pointer over here called the temp, and temp will be equal to t of a right child. Then next one, if that tree of right child is true, true means it becomes false. We won't work out. If it is false, then it will become the true. Then if it is false means what? We need to follow the left thread. We need to follow the left thread. If it is a true, only then, true means what? It will have its successor over there. We have to take the right child. We have to take the right child. If it is false, then we have to take the left child. So that we are taking. That is, we will take up the left child. So that will give the next element. It will give us the next element. That is the successor element over there. The successor element will take, how will take? If the thread value is true, if the thread value is true. So now true means what happens now? True, it will becomes false and will return the temporary value. If not, if it is false, then we'll take the left value. Left child will be the next element. Left child is the next element. Fine. So that is how we will find the in-order successor. So now to have the entire traversing of the in-order, to have the entire traversing of the in-order, so we call this one repeatedly. So that is, we start from the first node, then in-order successor of the temp. So it will go there and it will get its successor value and it is going to return that one, that will check. And if the temp what we are getting is nothing but your root tree, then we are going to break, or else the temporary value will be printed, or else the temporary value will be printed over there. So now if we take up this tree, it will be much more clear here. First case, what happens? Now the both the links are false. Thread values are false for this one. So here one is true, one is false. Here both are true. Here both are true. Let me name them A. Then the next one is here, let it be B. Here let it be C. And here let it be, sorry, connected. Here let it be connected here. Fine. So now here in this case, it will be first initially for the root node, both the threads are false. Here for the B node, the first left thread is a false, that is a true, that is it is connected to its in order, that is, let me call it as the root node here. So now this link is pointing to the root node. Fine. Then next one is a false because have a right child. So now this link A B C D, this link is pointing to its root. This is to its successor. This is to its predecessor. This is to its successor. Let me make the threads as the here the solid arrows. Here the solid arrows indicates your threads, your child, and the dotted one will are indicating your threads. Fine. So now in this case. So now if we continue the first one, first we go with the root node, then next we go with the in order successor over here. We start from the A. We'll start from the A. First will be we'll take up the link value over here, the root, the successor value. So we check it's a right thread value. What is the right thread value over here? False. False. Not of false means true. Lot of false is a true. Then we'll go to its left child. That is a temporary of left child will take up. Temp of a left child, even it is false over here. So now we'll take up the next one. The next one is a temp of left child. So I will come to the B again. So we'll take up the it will come over here again. Fine. Then next. So again the left thread. So now the left thread is now true. True means we'll stop. This loop we are going to stop and we are going to return the temp value. We check the temp equal to your root node. No, we are going to print that one. What is printed now? So now B is printed. B is printed. Fine. So now how it happened? First we passed A. So it will come over here A. Fine. For the A, what happens? A of right thread. A of right thread is a false. False, negate that one, that become true. It will enter into the loop. While I will look at the left thread. False, again negation, it will become the true. I will enter over here. Temp equal to temp of left child. So I will come to the B. Again, it is a while loop. Temp of left thread. What is the temp of left thread? It is true. So negation of true, it will becomes false. I will break this loop and I will come out. Return temp. Where we are there at the B. So B will be returned. B will be printed over here. So now I need to get the next element. Correct? I need to get the next element. To get the next element of the B, again, I will check at the right link. Right thread I will check. So now the right thread, it will pass over here, the right side. Fine. So now take the temp will be equal to tree of right child. What is the right child of the B? It is a D. So now again we will check. Temp of left thread. So now we are there at the D now. So now temp will be equal to tree of right child. What we have passed? B we have passed to get its next element. We passed B to get its next element. So now B will be copied to tree. B will be copied to tree. Again, tree of right child. B of right child. What is the B of right child? D. Temp is now D. So now check out the right thread over there. Right thread is a true. Negation of true. So negation of true is false. It won't enter into the if statement. Return the temp. Now what is the temp over there? D. So D will be printed. Now to get the next element of the D, again we'll pass over here. Temp equal to tree of right child. What is the right child of the D? Right child of the D is A now. Right child of the tree is A. So now it will come over here. So that is a tree of D of right thread. So D of right thread is my null. So D of right thread, D of, sorry, here, D, A. So A of right thread. So A of right thread will be my, that is the next element. My next element is now A. So A will be get printed. Then next we take the right child of the A. So the right child of the A is a C. So now again the link is null. So we'll take the right child. So that is a C. C will be printed. This is how the things will happen. That is by using the, now we are not used any stack over here. So instead we just followed the thread fields. By following the thread fields, we are able to get the successor element. So that will be the in order successor for without using the stack. The next, inserting a node into the threaded binary tree. Fine. So now if it is an empty tree, let us take the scenarios. If the right node is empty, if the right node is empty, then what are all the changes I need to make? This I need to connect over here. Its predecessor is this one. Its successor is root. Fine. So these are the connections I need to make. Let it be S, let it be R. Fine. That is R of right, sorry, S of right child. S of right child should be equal to R. The next one, R of left child should be equal to S. Fine. Then next, this one R. R of left thread. R of left thread should be true. R of left thread should be equal to true. Fine. Then next, R of right child should be equal to your root node. Your root node, or we can connect it as S of right child we can connect, and this we can put last. This we can put last. Fine. So this will insert R as a right child to an threaded tree if I don't have the right child over there. If I don't have the right child, then this will work out. If I have a right child, in this scenario, so now I have a right child over here. Now I need to insert here. I need to insert my node here. Now what and all changes I need to make? So this is S, this is R. Fine. So now this will be S, this will be R. Fine. So now what are all the changes I need to make? What are the changes I need to make? Fine. So first will be S here. This link, this is fine. So now this link, earlier it was pointing here. Now I need to make this to point over here. That is R of right link. R of right link should be equal to your S. S, let me call it as a parent. Parent of right link. So S is the parent over there. So parent of right link. So now this will make this one to point here. Fine. Then next one. In the next one. This left link, the predecessor is this one. So the predecessor is this one. Here, this node we are inserting. So now I how to connect this one? R of L link should be equal to parent. So now this will make the connection. This connection is done. The next one, I need to connect this one here. So this I have connected. R of right link to parent of right link. This I have connected. So next I have connected this one. Now I need to connect this one. So how to connect this one? How to connect this one? S of right link. S is nothing but your parent. Parent of right link. Parent or S, both you can take. Parent of right link. Parent of right link should be equal to your R. That is nothing but your child. Fine. So this will make the connection. So this is what we need to do if we want to insert as a right child, but the right child is already existing. Fine. So this will be explained with the help of the code. Fine. So the first one, the threaded pointer will be the temp. R of right child will be the parent of right child. The first connection we are making. That is, this is the parent. Fine. So earlier we have, let me write this one there part. Fine. So this earlier I have the link like this. So now what I will do, R of right child. So this is R. This is parent. R of right child. This of right child I will make it to point over here. Parent of right child. Fine. Then next one. R of right thread equal to parent of right thread. R of right thread will be equal to parent of, if I have any parent right thread, that is nothing but your false will be copied. Your parent right thread is false, that false value will be copied because I have a right child over here. the right child, since the right child is there, so I will put the right thread as a false. Then next, R of left child will be your parent. So now this left child, I will connect it to its parent. Then the left thread, I will make it as true. Then this connection I need to remove. So how to remove this connection? This is nothing but your yes. So yes of right child. Yes of right child will be your child. So now I will make the connection. So now this will be get connected. And yes of right thread will be equal to now false. Yes of right thread will be equal to false. The next one, if R of, if this itself is the ending, R of right thread is null. Null, again, if I negate it, it will become false. Then I need to connect to the temp will be equal to in order successor of the R, and temp of right child, I need to make it as R. Temp of right child, I need to make it as R. This is how I am going to insert the node as the right to the right as a right child over here. So this will be regarding creating the binary tree and making the in-order traversals for the binary trees. Right. The references for this presentation are taken from the textbook Ellis Oravis and Sartasani, Fundamentals of Data Structures in C, second edition, Universities Press 2014, and Lipth's Data Structures from the Shamla Outline Series, revised first edition, Tata McGraw-Hill 2014. Thank you.